Hi, my name's Alan Tsao, and I help students prepare for AP Physics 1. We've talked a lot about process on how to solve problems, and today I want to get into a specific process that's really key for all of you, and it's how to draw free body diagrams correctly. Now, I was never taught the specific rules around drawing free body diagrams, but I actually think it's super important. And so I've actually developed like what I say are the standard rules for drawing free body diagrams. This is what I'm thinking about, how when I'm drawing free body diagrams, everything to consider, because it is very systematic. It's not like experience. You just do a lot of experience, you kind of know how to draw a free body diagram. That's traditionally how it's taught, is to say like, here, this is how you just do a bunch of free body diagrams and eventually you'll kind of get what's happening there. I prefer that you have direct rules that we apply, and we apply them rigidly in every situation that we're going to be doing. Now, to keep it simple, I'm not going to be talking about friction, although I do have rules for friction, but I do want you guys to understand at least the basic ideas of what I think about when we're drawing a free body diagram when it involves three major forces. All right, so let's take a look at this now. So how do we draw free body diagrams? First off, there are three major forces that we're really going to talk about today, and those are the major forces. Other than friction, those are all the forces we need to care about. We have gravity, we have normal force, we have tension force. Okay? The first thing we always draw in a free body diagram is the gravity. Gravity always points down towards the center of the Earth. It's pulling towards the center of the Earth. That is the rule for gravity. Okay? Pulls towards the center of the object. I think most of you guys get that one. That one's not usually too hard to understand. Then what do I look at is I look at what else is physically touching the object, okay? Because all the other forces, other than gravity, all the other forces require physical contact with the actual object. So what we do examine is we look at normal force and tension forces. If it's a surface, the normal force is from a surface and it pushes outward from the surface, okay? And then tension force is from a rope and it only pulls. It pulls in the direction of the rope. All right? Those are the rules. Those are the three rules that we're going to follow for every free body diagram problem. All right, so let's take a look at this. Let's look at like some practice problems here. So we have this block, and they ask you on block M1, if you read the scenario, they're connected by a light string. These blocks, we're just going to do the free body diagram. We're not going to do the entire problem here. All right? These blocks are connected to a block of mass M. It's on the pulley. There's kinetic friction on the block of force on block 1 is F, little f. So they want a free body diagram of M1. So we do gravity first. I write as M1G, you can do gravity. Then I say, what is touching the block? Well, the ramp is touching it. The ramp exerts a normal force. Okay? There's a rope touching it. The rope pulls in that direction. And that's it. That's the free body diagram, excluding the friction. I'm going to ignore the friction one. We're not going to talk about today. But if there were friction, it would oppose the motion. It has some rules around that. That's it. That's the free body diagram for that guy. There's nothing else touching it. Notice that the normal force is perpendicular to the surface. It's pushing outward from the surface. That's why it points in that direction. Let's look at this one. An airplane accelerates uniformly from rest. He holds up a thin string, negligible mass to which is tied to the ring, which is mass M. She notices the plane accelerates down the runway and the string makes an angle theta with the vertical shown above. Draw a free body diagram. All right, well, here we have gravity. Always points down towards the center of the Earth. What's touching it? There's a rope touching it. Pulls that way. There's no normal force. There's no surface. There's nothing else touching it. Those are the only forces acting on it. And so we're done with that free body diagram. Let's take a look at this one. Let's do a free body diagram. Okay, so you can see here, this guy. Let's do a free body diagram of both of these blocks. We'll ignore the scenario. We're pulling on it and it's moving this way. So what's the free body diagram of this guy? All right, we have mg, or 8g. We have normal force. So then I ask, what's touching it? What is touching this? We have a surface right here, so there's a normal force perpendicular to that surface. There's this applied force. There's a force to the right, that's 4 newtons. And then there's a spring force. We'll just pretend the spring is going to be like a tension force. Spring actually has a few different rules. It could be pushing, could be pulling. But in this one, it is pulling. So we'll just call it that way. We'll just pretend that was a rope there. I'm just sort of coming up with scenarios. So let's pretend that was a rope and it's not a spring. So the rope pulls this way. How about this block? Well, he's got 2g, he's got gravity going down, m times g. Then he has a surface here, so there's a normal force from that surface. Then what else is touching it? The rope right here, and so there's a tension to the right. It pulls. Tension always pulls. So for this free body diagram, pulling means it's to the right. For this guy, pulling means to the left. It pulls in the direction of the rope. If I said the tension was to the right, that would be pushing it. It would be pushing the block to the right, but ropes can only pull. All right, let's take a look at this person. This person is just hanging here. And let's look at free body diagram of student A. We don't really worry about the scenario here. Let's just assume they're just hanging here. So student A, he's got gravity, right? And then the ground is touching him, so he's got a normal force. And then he's touching a rope right here. And the rope pulls. It pulls, which way does it pull? It can only pull upward, right? That's the pulling in the direction of the rope. How about B? B's got gravity, 60g in this case, or mg. And then he's touching a rope, so he's got tension also. Okay, and it pulls in the direction. Nothing else is touching him. He's got no normal force because he's not touching anything else. Right, so physical contact is really important. Okay, how about this? A small block, and they're asking a free body that this block is going to go around, and it's going to be like right here at the top. What are the rules? Well, we have gravity. And then we have a surface right above it. Now it's upside down. The surface is on top. So what is perpendicular to that surface is there's a pushing force downward like that. Because it can only push. If the normal force were pointing up, it would be pulling on the block, right? But it can only push outward from the surface because the surface is here. Pushing outward is downward. And that's the free body diagram. I'm not even talking about I don't even care about the circular motion. I'm just talking about how do you draw the free body diagram. And so that's kind of the idea. You want to follow those rules and get really, really good at that. Because if you can't draw the free body diagram correctly, the rest of the work doesn't really matter at that point. If you can't follow those rules, if you can't be accurate on there, it doesn't really matter what the next steps are because it's going to end up giving you the wrong explanation, the wrong derivation, and the wrong understanding of the scenario. So the free body diagram is super, super critical. Be very clear that you follow those rules. We do gravity, normal force, tension force. They have specific rules. And then maybe another time, if you guys are interested, I can give you the rules for friction, static and kinetic, and spring forces. Those are the only forces we talk about in this class. In AP Physics 1, those are the only forces. We're just missing friction and spring force. So comment below if that was helpful, if that added clarity, or if you had any other questions on that.